Okay, here's the first part of the lesson, 1.5G2, goals continue from day one. I apologize I didn't get printed notes, but in the interest of time, I wanted to make sure that you at least got the video. Okay, so for the sub, if it requires to pause at any point in time for them to write down a problem and so forth, go ahead and do so. First problem is going to be simplify, and again, our answer we want it to be in simplified or standard form of a complex number, which is a plus bi. Number one, I'm just going to give myself a little room here. We have 6 minus 2i multiplied by 2 minus 3i. So here we're taking the product of two imaginary numbers or complex numbers. So as we know in mathematics, we multiply numbers, and we're also going to multiply complex numbers. So let's see what happens. If we think of it in terms of FOIL or distributing, first we do 6 times 2, which gives us 12. 3 gives us negative 18i. Negative 2i times 2 gives us negative 4i, and then negative 2 times negative 3 gives us plus 6, and then I times I is I squared. Okay, so now we have 12 combined like terms. We get negative 22i plus 6i squared, if we recall, is negative 6. Or negative 1, excuse me. 6 times negative 1 is negative 6. Combine this with its like term, the constant, so 12 plus negative 6 will give us 6 minus 22i, and that is our standard complex form for number 1. For number 2, we have root negative 5 times root negative 10. If you do not do this in the correct order, you will not get the correct solution. If you think root negative 5 times root negative 10, such as the same as root 5 times root 10 gives us root 50, if you think of it like this, it will not work correctly. It'll give you positive root 50, it will give you positive 5 root 2. But keep in mind, we think of it generally or conceptually that we don't know how to deal with a root negative 5. However, we do know how to deal with root 5 times root negative 1 times root 10 times root negative 1. Root 5 times root 10, that we know combines to be root 50. And let me back up a step, I apologize. Let's now change it into what we know how to work with. Root negative 1 is I times root 10 times root negative 1, which is I. Now we can start combining. Root 5 times root 10 gives us root 50. I times I gives us I squared. Root 50 breaks down into 25 and 2. 5 root 2, I squared gives us negative 1. Move the negative out in front, that will give us negative 5 root 2. Before we move forward, let's talk about powers of I. And hopefully we'll see a pattern here. First off, I we know equal root negative 1. We saw something very interesting when we squared I. The root and the square canceled, and that gave us negative 1. So we square an imaginary number, we get a real number of negative 1. What happens if we cube it? Let's just see what happens. Well, I'll do this one, and then let's see if you can do I to the 4th. I to the 3rd, well, we could factor that out. I could factor that into I times I times I, which would really be root negative 1 times itself 3 times. I could also factor it, we're going to want a factorization that's going to work best for us, into I squared times I to the 1st. Why do I want to do that? Because I squared equals negative 1. And negative 1 times I to the 1st is simply negative I. When we cube I, we get negative I. What does that mean? Well, we'll see as we move forward. Right now we're just practicing a skill of seeing when we cube an imaginary number, or I, we end up getting negative I. With that, try to break down I to the 4th. Sub, if you could pause it right here. One way you can break it down is I squared times I squared. If you do that, I squared equals negative 1. I squared equals negative 1. Negative 1 times negative 1 gives you positive 1. So I to the 4th will give you positive 1. Note, if you did I to the 4th times I to the 3rd times I, a little more challenging, but I to the 3rd equals negative I. And then you have an I there. Negative I squared is the opposite of negative 1, which equals 1 as well. Now let's look at I to the 5th. Go ahead and try I to the 5th. Sub, if you could please pause the video. Okay, now let's try I to the 5th. You can break it down any way you want, but I to the 4th is really nice. because I to the fourth equals 1. So if I insert 1 there, 1 times I is simply I. So I to the fifth equals 1. No, it doesn't. I apologize. It equals just I. Once again, I'm sorry. I to the fourth equals 1. 1 times I is simply I. I to the fifth goes back to I. Let's try I to the sixth. Now note, when we use I to the fourth, that worked really nice. It turned into 1. Let's do the same here. I to the fourth times I squared. I to the fourth equals 1. I squared equals negative 1 using our table. 1 times negative 1 is negative 1. So I to the sixth equals negative 1. Hopefully, we're seeing a pattern here. I through I to the fourth goes in the pattern of I, which is root negative 1, which we represent as I squared is negative 1, I cubed is negative I, and 1 is I to the fourth. Look what we have here. I, negative 1, just the same as we have up here. So, following that pattern, I to the seventh, if we factored it, we would find that it equals the same as I to the third, which is negative I, and then I to the eighth will equal the same as I to the fourth, which is 1. Quite interesting. When we take i's to powers, it doesn't get larger and larger or smaller and smaller like real numbers. Think if you square or take a fraction like 1/2 or whatever to the fourth or the eighth, etc., it's going to make it larger and larger. In this case, it repeats in this pattern over and over again, which comes to some very interesting patterns when we get into graphing. But that's not what we're working on now. I just want you to see that there's a pattern. And what's most important is the I to the fourth. I to the 4n, n being some integer, will always give us 1. So if n is 1, 2, 3, etc., that means I to the fourth, I to the eighth, I to the 12th, I to the 16th, etc., will always equal 1. Therefore, example number 3, here's your example number 3. If I have I to the 67th power, I know if I can break this down into I to some power or some exponent that is a factor of 4, that will turn into 1. So, I to the 40th, I'm trying to look for numbers close to 67. I to the 40th would equal 1 because 40 is a multiple of 4. I may have said factor before, I meant multiple. And then I look at 40 and 60. Well, that leaves us with 27, a difference of 27. 60 and 40 leaves 27 to go up to. So, less than 27, what is your multiple of 4 that is just less than 27? That would be 24. So 24 more than that, if I had 24, that would be I to the 64th power. That is, 64 is the multiple of 4, the largest multiple of 4, just less than 67. And we add exponents, so I to the 64th times I to the third will give us I to the 67th. 64 is the largest multiple of 4. That's what you're looking for. That is just less than 67. That turns into 1, and we're left with I to the third. And then we simply use our table. I to the third equals negative I. So I to the negative 67th equals negative I. For number 3, we have root negative 2 to the 6th power. Once again, we don't know how to work with the root negative, but we do know how to work with I, so we break that down into root 2 times I to the 6th power. And now we distribute root 2 to the 6th and I to the 6th. Root 2 to the 6th, remember our index is 2 and we divide them, so that would be 2 to the 3rd. I to the 6th, if we break that down into I to the 4th, I squared. 2 to the 3rd is 8, I to the 4th equals 1, I to the negative, or I squared, equals negative 1, 8 times negative 1 will give us negative 8. 4, if we have 1 over 2I to the 3rd, that would be, we're already in terms of I, so we don't have to turn it in terms of I like we did with the root negative 2. Let's go ahead and cube it. We have 8I cubed I cubed turns to negative I, that's multiplication, and if I move it out front, that will give us negative 8I. We also have, or we're good so far, but we have an I in the denominator, which is a radical. It only has one term in it, so we just simply have to multiply top and bottom to get a perfect square in the denominator. That'll give us I in the numerator. We have negative 8. Note you can move the negative up top. We'll see what happens here. I times I gives us I squared, which equals negative 1. So I have I in the numerator, negative 8. I'm going one step at a time, times negative 1, which will turn into I over 8. Note, it would be nice to have it in complex number form. If you keep it like that, you that'd be fine, but you could also write it as 1/8. Okay, next problem. Solve this quadratic. You can use completing the square or quadratic formula. It's the exact same thing as we always done, but now we're going to get imaginary numbers for solutions. If we use a quadratic formula, x equals negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. X equals negative 16 plus or minus root 256. 4 times 4 times 17 is negative 272 all over 8. If you combine those two, you end up getting, inside the radical, you end up getting root negative 16 over 8. And then root negative 16 equals 4i all over 8. We have 4 in each term, so we reduce by 4. It'll give us this. Put it into imaginary number form. Divide both by 2. Negative 2 plus or minus. You have 1i, so you have 1i over 2, which in standard complex number form would be negative 2 plus or minus 2. That concludes 1.5 lesson. The next video will be the 1.6 lesson.